We shall start by what is the meaning of statistics. It is defined here that it is a science of collecting, organizing, presenting, and we also have that aspect of interpreting the data to assist in decision making. So the key thing here is about the data. Data is the key term here. And what we refer as data, it is actually any information that can be manipulated or that we can be able to analyze to assist in the decision making. So when we get that particular information in a way that it has not been processed, it is normally referred as the data. So if I go ahead, maybe I measure the students' height in a particular class. As I measure those students and record down their heights, I'm collecting data. As I go maybe and try to find out the total exports or imports in a particular year, as I write down the imports or the exports for each and every month, as I note them down, I'm actually collecting data. Once I have that data, I can organize that data. Maybe I can organize in a way from the highest to the lowest or something like that. After organizing that, I can present. Presentation here, it is actually the graphical or tabular presentation of that data. I can choose to draw a pie chart from that particular data. I can choose to draw a histogram or a bar graph or any graph that I may choose to present that particular data. And then after doing that, I can go ahead now and do an interpretation or analysis on the same, whereby I can go ahead and calculate the mean height, the mean import, and things like that. That is now the analysis part, and then I can be able to interpret that particular data, whereby I can say maybe in this particular class, the mean height is this, or the shortest person in this class is this. Actually, that is what we mean. But now, the important part of it is for you to understand what we are referring here. We shall be referring as data. Data is when we extract the raw information so that now we can process that particular data to be information. Actually, information, it is data that has been processed. And once we have the information, it can aid in decision making. So basically, we have got two types of statistics. We have got what we call the descriptive statistics and the inferential statistics. That aspect of drawing the graphs, the pie charts, the histograms, the line graphs, and all that, it is that part of the descriptive statistics. And then we have the inferential part, whereby now we can be able to maybe to get the mean, we can be able to get the standard deviation, and all that. That is the part of the inferential statistics. Then in statistics, we are going to also to come across the variables. What we normally refer as a variable, it is any characteristic that is actually measurable. Like for example, the age can be a variable. Just a minute. I was saying a variable is anything that can be measurable. Like for example, age is measurable because we can be able to do that. It can be the marks, it can be the distance, it can be the profit. All those things that we can be able to measure mathematically or quantitatively, they are known as the variables. We have got different types of variables. We have got those variables we refer as the independent variables. Independent variables are actually the main concern. Actually, what we need to determine, we can have, for example, the amount of harvest. The amount of harvest is going to be maybe determined by what we refer as the dependent variable. We have the inputs in the farm setup, like the fertilizer and all that, and then we have the output, which is actually the amount of harvest. So the inputs are normally referred as the independent variables because they are going to drive what we refer as the dependent variable. So here, the amount of harvest is depending, so it is dependent on the independent variable, which is the input. So the inputs, the more we have maybe high or good quality inputs, the dependent also becomes high and of good quality. If, for example, we put enough fertilizer or more fertilizer, we are going to witness more harvest. So this independent will cause a change on the dependent. So the dependent actually, from the word itself, dependent, it depends on this other variable. Then we have got those variables we call qualitative variables. These are variables that cannot be expressed numerically, like, for example, the beauty, we have gender, region, things like that, motivation. They are qualitative variables. They cannot be expressed numerically. Then we have the quantitative variables, are those variables that we can express them numerically. As we have said, things like the age, the profit, and all that. But under the quantitative, we can have either this discrete variable or continuous variable. A discrete variable, it is a variable that assumes one particular value. Like, for example, if you say that student A scored 30 marks, that 30 is discrete. But when we refer to continuous, it is when we have a range. We can say those students who scored maybe from 20 to 30, they are maybe 15. So when we give a range, that particular or that variable is now continuous because we don't have a specific value, but that value can be anywhere between what you have, the lowest and the highest. That is called the continuous. But the discrete, if we say is called 30, that is discrete. The specific value, which is actually non-negative, is actually referred as the discrete. But when we give a range, that variable is actually referred as the continuous. Then we have got those variables we call controllable, and we have those we call uncontrollable. The controllable are those that you can be able to manipulate as an organization. You can be able to change. You can be able to adjust. Like, for example, the price of commodities, you can adjust the budget and things like that. So anything that is within your your ability to change falls under the controllable. The uncontrollable are those variables that you cannot be able to change. They are actually external factors, like maybe political instability. We can have maybe things like amount of rainfall, the competition from maybe your competitors. Those are external factors which, as an organization, you don't have any ability to change them. So those are basically the types of variables that are normally witnessed in statistics. Then we can talk about the characteristic of statistical data. One, it is an aggregate. An aggregate, like, for example, when we say that the mean is the mean in a particular class, in a particular subject, we say maybe it is 50%. That is just an aggregate. It does not mean that everybody in that class scored 50, but we are actually trying to find where majority of the students were lying. And then they are affected to a marked extent by the multiplicity of causes, e.g. the volume of wheat production depends on rainfall and all that. And they can be numerically expressed. Actually, in statistics, in this particular actually unit, and any statistics that is normally done in academic world, we normally deal with the numeric. We don't deal with the qualitative. We normally deal with the quantitative variables. And also, they can be estimated according to a reasonable standard of accuracy, what we normally say the level of accuracy. In most cases, it can be 90% accuracy or 95 or 99, depending on how you can be able to trust the whole process. And they are corrected in a systematic manner, meaning that there is a procedure that is normally followed, and they are corrected for a predetermined purpose. Before you go to correct data, there is something or there is a decision that you want to make. So you go correct that data so that you can be able to make that particular decision. And then lastly, they should be placed in relation to each other. We can say that the mean score of this class this year is 50% versus the last year maybe, which was 48. So we can say there was an improvement of 2%. And we have the uses of data, or how data is used and who uses them. We have got the highlight there, which you can be able to go through. And we can come to this part of the limitation of statistics. One, it is based on aggregate. Aggregate, we said, is actually average. When we come and say that the class performance was very poor, and as a result of that, maybe the mean is 35%, that is an aggregate. But you can find in that particular class, there's a student who scored maybe 90%. So we can come here and you say it was very low, but there is something, there is maybe a particular item that is actually doing very well in that particular case. And it deals with the quantitative characteristic. As we said, statistics concentrates on the quantitative variables, and therefore it does not focus on the other variable, which is the qualitative. So qualitative variables are normally omitted, though they are very important in affecting the performance of an organization. Like, for example, something like motivation, it is very, very important as far as the performance of an organization is concerned. But such kind of a variable is normally disregarded when we compute or we talk about statistics. And also another limitation is that the results are only true on an average under certain conditions. And the other limitation is that statistics can be misused, or if we don't do a very good correction, interpretation, and analysis, then we are going to make maybe a wrong decision for that case. And statistics may not provide the best solution under all circumstances. Certain circumstances, statistics cannot be applied because of the nature of the situation. Having said that, we can go to data correction. How do we correct data? Here, we are going to focus on the data sources. We have got two sources from which data can be corrected, and those sources are either secondary or primary. If I can start with the primary here, primary data sources, it is when we correct data in its original form. In its original form here, I mean, it has never been corrected before. It is the first time we are collecting this particular data. It is the first time we are collecting this particular data. And this particular data is corrected through three ways. We can correct it through interviews, through the use of questionnaires, or through the interviews, questionnaire, or observation. Those are actually the three ways we can correct the primary data. But the key thing, remember, it is the kind of data that is original. Original in the sense that you are the first person to correct that data. So either you observe, if I am a manager and I want to correct the statistic on the arrival of my employees in the organization that I'm managing, I can sit somewhere and observe them as they check in. And then I can be able to make the conclusion. That is now the observation part of it, the use of eyes. The other is the interview. You can call people and you interview them so that you can get the information from them on a particular issue that you want to come up or to calculate in statistics. And the other one is the questionnaire, where you issue the questionnaire as a document, the respondent respond, and then you sit down and analyze that particular information. But the key thing, you are the first person to correct that data, and that's why it is called primary data. The secondary data, it is actually information that was corrected by somebody else and it was recorded, either in books, in magazines, in journals, periodicals, and all that. So your work is to go and get that book and review and use that data which was corrected by somebody else. So if you are using information that was corrected by somebody else who documented that information, then you are doing the secondary data. So secondary data, it is the information that was collected and stored. Now you retrieve it and then you read and you use that information in making the decision. The advantages and disadvantages of them, they are highlighted there. My key now area that I want to spend some minutes is on data presentation. Data presentation is actually an area that is tested more often. So, and in this case, I'm going to demonstrate how we present data in each and every category of data presentation. So allow me to share my screen for writing. So here, our focus at the moment is on data presentation. So presentation here, I said it is either you draw things like the graphs, you draw things like the bars, let us call it the bar graphs. This one, it can be a line graph. We have things like the pie chart and all that. But the bottom line is that data presentation, it involves pictorial. It involves pictorial presentation. So we use something like a picture so that we can present that data so that people can be able to read it or analyze it and make the decision. So I want to start with the first one, which is actually the histogram. How do we prepare the histogram as a data presentation tool? So first, a histogram is going to have bars which are joined together. The characteristic number one, we have the bars that are joined together. And then the height of those bars, the height will be equivalent to the frequency of each and every bar. So we can have information like this. Allow me to open a new page to demonstrate on the histogram. You can be given information like this. We have the age, maybe it is 10 to 20, 20 to 30, 30 to 40, 40 to 50, and maybe 50 to 60. This is actually the age of people who participate in morning race, those who go out to do a practice in a particular day. So in a particular week, the information was recorded as follows. Those between the age of 10 and 20, they were 5. 20 and 30, they were 15 people. 30 and 40, they were 10. 40 and 50, 20, and here we were having 15, like that. So 10 to 20, 5 people were doing the practice. 20 to 30 years, 15. 30 to 40, they were 10. 40 to 50, 20. And 50 to 60, they were 15. Then you are asked, present this information. Present this information on the histogram. So what you need to do is to come here, have the X and the Y axis. On the y-axis, you are going to have the frequency, the number of times these are appearing. So here we can break this one and we start with 10, 20, up to 60, because we have got between 10 up to 60. So here we have our 10 up to 60 at that point. Between 10 and 20, they were 5. Let me write here. Maybe we have here 5. Here we have 10. Here we have 15. And here we have 20. I think that is the highest that we have on the frequency. So between 10 and 20, we can come here and we draw a bar that is having a height of 5. And we join it up to 20 like that. So between 10 and 20, the height is up to 5. Then 20 to 30, the height is up to 15. So we extend this one up to that point. 20 to 30 is up to 15. Then 30 to 40, 10. 30 to 40, it goes up to the height of 10. So we join it like that. 30 to 40, the height is 10. Then we have the other bar, which is from 40 to 50, it is 20. 40 to 50 is supposed to go all the way up to where we have 20. So we bring it down. So 50 is supposed to be actually here. So that is the next bar. And then the last bar is up to 15. So that is our histogram. The characteristic of a histogram is that these bars, the way they appear, they are all joined together. they are all joined together. We don't have a gap between the two or between any particular bar. They are actually continuous like that. That is actually what describes the histogram. The height of each and every bar is actually equivalent to the frequency of that particular class. So whatever we have here, it is classes 10 to 20. You come here 10 to 20 and make sure it has the height equivalent to that frequency. So the height is up to 5 because here we had 5 as frequency. 20 to 30, the frequency was 15. So the height goes up to 15. And then whatever comes out is your histogram. This was a very direct one. In some cases, you can be given information like this. You can be given information where maybe you are told that I still use the age. You can be given information like 0 to 5, 6 to 10, 11 to 15, 16 to 20. And then you are given here the frequencies. So you are given maybe this one was 8, this was 10, this one was 6, and maybe this one was 12. You are told now, present this information on a histogram. If we go direct and plot as we said, you will find that we are going to have the gaps because this information is not continuous. If you can be able to look at what we had here, 10 to 20, 20 to 30, you can be able to realize that the upper limit of the first class becomes the lower limit of the next class. The upper limit here becomes the lower limit here, upper limit becomes the lower limit, and like that. And that's why these bars are all joined, because where this one ends, it is where the next one begins. Where this one ends, that is where the next class begins, in that order, in that order. But in this particular case, if we go and plot this one goes from 0 to 5, but the other one starts from 6 to 10, the other one from 11. So you can be able to realize between 5 and 6, there is going to be a gap there. Between 10 and 11, we are going to witness a gap there. The same case, 15 and 16, there is a gap there. Anytime you are given information like this, what you need to do is to make it continuous. You need to rearrange it so that we have a continuous kind of data. You should come here and have them appear like this. So on the classes, the lower limit and the upper limit. On the lower limit, you subtract 0.5. You rest 0.5 on the lower limit. You rest 0.5 and then add 0.5 on upper limits. 0.5, you less it from the lower limit, then add 0.5 on the upper limit. So what you are going to find is this. If we leave around the first one, let us just go to the upper limit of the first class. If we add 0.5 here, we are going to find it is going to be 0 to 5.5 if we add 0.5 here. If we come here, this is the lower limit, this is the upper limit. On the lower limit, we less 0.5. So if we less 0.5 here, we are going to have 5.5. And if we add 0.5 here, we are going to have 10.5. If we less 0.5 here, it is going to be 10.5. If we add 0.5 here, we are going to have 15.5. If we less 0.5 here, we are going to have 15.5. And if we add 0.5 here, we are going to have 20.5. By so doing, your data now becomes continuous. This one is up to 5.5. This one begins from 5.5 to 10.5. This one begins from 10.5 to 50. You'll find that where this one ends, it is where this one starts. And your bar is going to be continuous in that particular case. So if you go ahead and present this information now on a histogram, your histogram is going to be something like this. Allow me to lab this. You are going to have something like this. So here we have the age, and here we have the frequency, which is your y. So we can have from 0, just go direct 5.5, 10.5, 15.5, and 20.5. Now, the frequencies I forgot to write, but I can come here and guess. The frequency, maybe they were 8, 10, 6, and 12, something like that. So if we come here, we can write it. Maybe we can have a scale of 2, 2. Maybe this is 2. We go to 4, we go to 6, 8, 10, and then we have our 12 there. So 0 to 5.5, 0 to 5.5, the height is 8. So we can have something like that. 5.5 to 10.5, the height is 10. So we can extend this one like that, because it should start from 5.5 as indicated here, and then we have it like that. From 10.5 to 15.5, the height is 6. From 10.5 to 15.5, the height goes up to 6. And then the other one, the height is up to 12. So what comes out now is your histogram, which is continuous. We don't have any gap between these particular bars. So note that if you are given information that looks like it is not continuous, it is your obligation, it is your duty to make it continuous, so that now we can fulfill the characteristic of what a histogram should be. We should not have any gaps. That is the histogram. Anybody with a question? Okay, if there is no question, let me go to the next way of presenting data, which is the frequency polygon. The frequency polygon, which borrows a lot from the histogram. In this case, the x-axis is going to have the midpoints. And then the y-axis, it is going to have the frequencies. Then we join those points using a ruler. We join those points. So what we can basically do here, let me use this one first. We had this histogram. The frequency polygon can be prepared using two approaches. We can prepare it using, after drawing actually the histogram, after drawing the histogram, we can go ahead and prepare or draw the frequency polygon on the same diagram. And what you need to do is to mark the midpoints. Between 10 and 20, there is going to be 15 there. The midpoint is actually the mid-row of these classes. You just add this, and then you divide by 2 to get the midpoint, the mid-row point. This is 30 divided by 2. You find that the mid-row point is going to be 15. 20 plus that is 50 divided by 2 is going to give you 25. 30 plus 40 is going to give you 70 divided by 2 is 35. This one is 90 divided by 2 is 45. This is 110 divided by 2 is going to be 55. Actually, those are the midpoint, 15. This one, we have 25 here. We have 35 there, 45 there, and 55 there. So because we are supposed to plot versus the frequency, so if you come the midpoint here and then you go to 5, you'll find that we are going to mark those points there. The midpoints of those particular bars at the top. Because for example, the first one is supposed to be 15, 5. If 15 is at the mid row and then we go to 5, it's going to be at the mid row of the top here. This one is supposed to be 25 on the x-axis, which is this point, and then we go to 15, which is actually this point. So it's going to be at the mid row of the top bars, like that. After having marked these points, you can come now with the ruler and then you join them. Using a ruler, you join them smartly, like that. And the curve or the line that is going to come out is now what we call the frequency polygon. So basically, the frequency polygon on the x-axis have the midpoints, and then on the y, you use the frequencies that you have been given. Mark those points, join them, you get your frequency polygon drawn. But you can draw it afresh. You can draw it afresh By drawing it afresh, you just come and have those midpoints indicated here. Like in our case, we had 15, the other one was 25, 35, 45, and 55. And then here we have our frequencies, which was 5, 10, 15, and maybe 20. You just mark 5, and maybe it was up to 5, you mark it. 25 and 15, you mark it. 35 and 10, you mark it. 45 and I think it was 20, you mark it, and maybe that one was 10, you mark it. After doing so, now join these points using a ruler so that you can have your frequency polygon. Is going to be a line behaving like that. So frequency polygon, you can be asked to draw the histogram and the frequency polygon on the same, or you can be asked to draw the frequency polygon on its own. If it is on its own, have the midpoints here versus the frequencies, and then join those points strictly using a ruler. Having said that, we can present data also through the use of the cumulative frequency. The cumulative, which we normally call the ogive. The cumulative frequency curves, or the ogive. So if you have your data, you can come up with this particular curve. I hope you can be able to recall from high school, we used to draw it, a curve that is behaving like that. It is like an elongated S, whereby on this side we used to prepare using the upper limits, and here we have the frequency. The frequency. If, for example, you have this, you have, for example, a data of 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and you have your frequency here, which is maybe 10, 13, 8, 4, and 6, like that. So these classes, the lower number, we normally call it the lower limit, and the other number on the right is normally referred as the upper limit. So you can come here and have a column for cumulative frequency. We can have a column for cumulative frequency, whereby we add these frequencies down the table. We normally start with the first one here, which is 10. Then we do 10 plus 13 is going to be 23. 23 plus 8 is going to give us 31. 31 plus 4 is going to give us 35, plus 1 is going to give us 41. And actually, that is what you are going to find or draw on this side. You are going to have the cumulative frequency, and here you have the upper limit. So in short, you come and you record this, whatever you have here, to be the upper limit. So you are going to have the 20, 30, 40, 50, up to 60. That is your upper limits. And here you have your cumulative frequency. So you just plot this. So like, for example, where we have 20, we should go up to where we have 10. So you just plot 20 versus 10, you mark that point. You go to 30 versus 23, you mark that point. You go to 40 versus 31. So these are going to be on your x-axis. These are going to be on your y-axis. So just go to the notes that you have. You are going to find it well elaborated and also presented. And then we also have the line graph. A line graph is a normal line. You are given the values on what to put on the x-axis and what to put on the y-axis. You mark them, and then you join those points, you come up with a line. So my main concern for this particular section, having said about the histogram and the others, I want us to do number 5, which is actually the bar graph. The bar graph and the different types of the bar graphs that we can have. The bar graphs. The bar graphs, they are actually of 4 types. We have got what we call the simple bar graph. We have got what we call multiple bar graph. We have got what we call the component bar graph, and we have got what we call the percentage bar graph. So the difference between the bar graph and the histogram is that the bar graph, the bars are normally spaced between one bar and the other. Remember, the bar is actually this rectangle that goes up. This is what we call the bar. The bars are normally spaced, and these bars, they have got the same width. The same width meaning that the distance from this end to this end is actually the same. So if we draw this bar and we have another bar, this width from here to here and this one, they should always be the same. They should always be the same. So we should not have a bar graph whereby one bar is so wide and the other is so slim. We should standardize them and have them the same. I want us to demonstrate how do we prepare these types of the bar graph. The component and percentage bar graphs are highly tested in your case, so they are worth noting how they are prepared. So we can have, and this example, let me demonstrate the simple bar graph. You can be told the production of food crops in a particular farm was as follows. So you are given the crops. They can be, we have the maize, we have the beans, and we have the potatoes that were produced. And then we have the production in kgs. So this one maybe was 240 kg, just put an example. And then we have this one is 190, and this one is 100. We can be told to present this one on a simple bar graph. If we prepare a simple bar graph, on the x-axis, we normally have these items that cannot be expressed numerically. So we can have the crops here, and then we can have the production here. So the crops here, we have the maize, we have the beans, and we have the potatoes. So for the maize, the production was 240 kg, so we can have it as what? Let us use a scale of 50-50, 50, 100, 150, 200, and maybe we have 250 there, yeah? Just to illustrate. So for the maize, the production was 240. So you need to come here and have that bar going as high as 240. So you need to mark it because you will be drawing this one on a graph paper. You can be very accurate. That is for maize. And make sure now from this bar to the next, there must be a space here. There must be a space. For the beans, the production was 190. So we need to come here up to where we have 190 and have our bar for the beans. But make sure there's a gap here. And then now, the last one is potatoes, which was having a production of 100 kgs, like that. So the height here is 100. And also there's a gap here. So as you are drawing your bar graph, remember this. These bars, they are supposed to be of the same width. That is number one. Now it is only the height that differs. Number two, they should be spaced, and actually the space should be constant. If you have chosen to skip one box here, you also skip one box here so that the spacing is actually uniform and the bars are going to have the uniform width. It is only the height that differs. And then maybe we can come here and we can mark that one that way. We can mark this one or shade it this way, and then we can have that one. That is actually a simple bar graph, a simple bar graph. We can have now another case of a multiple bar graph. A multiple bar graph. Maybe you are given these. There is 2001, 2002, and 2003. The production, so we have the maize, the beans, and our potatoes. So 2001, maybe it was 200, 150, and maybe 90 here. Then here it was maybe 240, 180, and maybe 120. Here they were having 250, and maybe here we can talk about 200, and here we can talk about 80. Now you are told to prepare the multiple bar graph. So with the multiple bar graph, you need now to come here and draw them this way. So this will be our case. So we are going to have years here, and we have the year 2001, 2002, 2003. Then we have got, each year we have got 3 crops that were grown. So we can come here. The highest is actually 250. Let us use the same scale of 50, 100, and up to 250, like that. So if we were to draw this, this is how they will appear. For 2001, the maize is 200, so we can come all the way up to 200, have it like that. The beans is 150. They are actually joined. For that particular year, you make sure that they are joined together. For the beans, it is like that, 150. And then for potatoes is 90. You have them like that. So we can say that this is for maize, this is for beans, and this is for potatoes. So you make them joined like that. Then now, when you go to the next year, you skip. You make sure that there's a gap between 2001 and 2002. So for 2002, the highest, or the maize, was having a production of 240. So we can have 240. For beans, it is 180. So you go up to where you have your 180. And then 120 for potatoes. So you locate your 120 and have it like that. So you shade, this one is for maize. This one is for beans. This one is for potatoes. That is the year 2002. Then you go to 2003. You make sure that there's a gap again here. So 2003, the beans, the maize, first of all, it is 250. So the bar should go as high as 250. For the beans, it is 200. So it will go up to where we have the 200. And then for the potatoes, it is 80 for this particular year. So you can come here and draw. So again, you can have that. That is for maize. That is for beans. And then we have the potatoes. So you can have something like a key here. And you tell the examiner that these bars that are shaded like that, it is for maize. The ones that are shaded like that, these are the beans. And the ones that are shaded, this one, are the potatoes. And actually now this is a multiple bar graph. In each particular category, we have got different bars, more than one. Actually, you can have 2 items or 3 items or even 4. But those 4, because they are for that particular category, they are joined together. When you go to the next category, you skip a gap, then you present the same. You also go to the third category and you do the same. Note again, these bars, they must have the uniform width. It is only the height that differs. As you skip this gap, make sure that this gap here, it is the same as the gap that you have skipped here in terms of the dimension. That is actually the multiple bar graph. I want to use this one so that I can be able to demonstrate the other two, the component and the percentage bar graph, by getting the totals here. If we add this, can somebody please add for me this? Add for me these quantities from 200 up to this point so that we can have the total here. 200 plus 150 plus 90.
440.
Sorry?
440.
For 40, thank you. The other for 2002, the total production, 240, 180, 120.
540.
540. 540?
Yeah. Yeah.
For 2003, can you add 250, 280?
530.
530, thank you. So when you are told to prepare the component bar graph, this is the component bar graph. This is how we do it. So we have the year 2001, 2002, and 2003. Now, we normally use the total. Make sure you have the total. So in this case, 2001, the total is this, the total is this and this. Let me have that scale first. The highest we have here is what? The highest is 540 of this total. So I can choose maybe to have a scale of 100, 200, 300, 400, 500, and maybe we go up to 600 so that we can accommodate all those. For the 2001, the bar is having a height of 440. So 2001, we draw a height of 440. You locate where 440 is, you just have your bar like that. The other one is having a total of, or let me finish with the 2001. We have got a height of 440, but this height, it is comprised of 200 for maize, 150 for beans, and 90 for potatoes. So what you'll come here and do is this. You will come here from where we have our 0, you locate 200, you come there and you say that this is the maize. That is the component for maize. Then beans was having a production of 150. So you will come here. After doing the 200 for maize, you can add 200 plus 150. It is going to be 350. So 200 plus 150, it is 350. So it is somewhere there. You come here and you shade. That is the component that is presenting the beans. And now from 350 to the remainder, to the total actually, from 350 to the total 440, it is actually 90, which is now presenting the potatoes. So you will come here and you shade, you say this is the component for potatoes. So they are all going to be in one bar, but that bar you subdivide it into component, and that's why it is known as the component bar graph. So you will go to the second year and get the total first. The total is 540. So our height should go up to where we have 540. Make sure there is a gap. So we shall go up to where we have 540, like that. And then you come here. For that 540, 240 is for maize. So come here and start by locating the 240, which is for maize. You shade it, that is for maize. You go and then find out 180 is for beans. So you add 240 plus 180 gives us how much? Or what is the figure there? For 20?
For 20.
For 20. So we need to come here. We need to come here. This is 240. We go up to where we have 420. 420, it can be somewhere there. You shade it, that presents the beans. Now the remainder for last, so that we can reach 540, is actually the potatoes. Then you do exactly the same for the year 2003. You get the total, which is 530. So your bar should have a height of 530. Sorry. Should have a height of 530. Sorry. have it like that. So do the component for the maize. The maize was having a proportion of what? 250, 280. So you'll come here, start by the 250 from down, where we have 250, mark it, say that is the portion for maize. Then the other one was 200. So if we add 200 to 250, we are going to go up to where we have 450, like that. Mark that is the portion for beans. And the remaining portion there, it is going to be for potatoes. Have a key. Say that this is for maize. This is for beans. And this is for potatoes. That is your component bar graph. So the bars are going to be actually be subdivided into components. Instead of having them in multiple form, the way we had them here, the way we had them under the multiple, you have it on one bar, but each bar is going to be subdivided into components. They are actually piled on top of one another. Then we can do the last kind of a bar graph, which is known as the percentage bar graph. The percentage, from what we know about percentage, actually, we are talking about, we convert those figures into percentages. Percentage bar graph. So with the percentage bar graph, we normally have your bars almost the same way with the component. Sorry. I think with the percentage bar graph, it's actually very simple. We normally have it up to 100%. All the bars, they have the same height. So we can have, this is 10. Make sure all the bars are up to 100%. Sorry, 10%, 20, 30, up to 100. So all the bars are going to be having a height of 100%. Like that. Therefore, you will do this. Let me come back here where we have our figure. We have, like, for example, the year 2001, or I rub this part so that I can be a bit organized. So you have this. I'm talking about the year 2001. The total was 440. So you express this one as percentage. So if we can start with the maize, you calculate what is 200 over 440 times 100%. You convert it into percentage. What about the beans? The beans, they were 150 out of 440 times 100%. For potatoes, they were 90 out of 440 times 100%. So you calculate these percentages. So somebody to do for me this, and somebody else this, and somebody else this, so that I can demonstrate that. 200 over 440 times 100.
45%.
45%, thank you. What about the second one? 150 over 440 times 100.
34%.
34%. What about for potatoes? 90 over 440?
20%.
20%. If I add this, they are supposed to give me 100%. Are they coming to 100%? I know because of rounding off, eh? Because of rounding off, they are supposed to give us 100%, but I can see it's like they are 99, eh?
99, yeah.
But I know it is because of rounding off, but if you write them without rounding off, they will add up to 100%. So what you need to do in your preparing, in your percentage bar graph, you need to note these percentages. The maize has got a percentage of 45, beans 34, and the other one 20. So you should come here and have that bar for 2001. It should have a height over 100 because it is percentage. All these are percentages. So you locate where you have the 45. 45, it is somewhere there. This is the portion for maize. The other one is 34. So you add, what is 45 plus 34? 45 plus 34?
70.
79. 79 is almost 80 here. So you mark it like that. That is the portion for beans. And then the remaining portion is for potatoes like that. That is for 2001. For 2002, you do the same. You will come here. This is 2002. You calculate the percentages now. It is 240 over the total 540. That is the maize. 240 over 540. Then you convert it into 100%. For beans, you calculate it is 180 over 540. 180 over 540. You multiply by times 100%. You get that. And for potatoes, is going to be equal to what? 120 over 540. Then you multiply by 100 there. So can you give me these figures so that I use them to demonstrate?
44%.
For maize, it is 44%. The other one?
14%.
14.
33%.
I don't know why you are breaking. Can you come again? For this year?
That is 3%.
Okay, thank you. And then the last one?
22%.
So actually, without rounding off, they should be 100%. So you come again now and you do the same. You start with the maize 44, and then you add plus this one. So it is going to be like this. For 2002, you make sure again it goes up to 100%. So you start with the 44% somewhere there. Somewhere there. You shade it. This is the portion for maize. Then plus 33 is going to be 77. You mark it. Then the remainder is actually for potatoes. This is for the year 2002. And what comes out is the percentage bar graph. That is going to be your percentage bar graph. That is how simple you prepare them. You do the same to the year 2003. You start by computing the percentages for each and every product. For maize, it is 250 of 530 times 100. This one is 200 over 530. This one is 80 over 530 times 100. You have those percentages. Then come here and have your bar that goes up to 100%. Then subdivide that bar in proportion to the percentages that you have calculated, and you have your percentage bar graph. So all the heights, all the bars, they have this height of 100%. That is that as far as the bar graphs are concerned. So the percentage bar graphs and the component bar graph are highly tested, but you should not also ignore the other two, the simple and the multiple bar graphs. Having said that, I can briefly talk about the pie chart, which is another way we can present our data. The pie chart is simply a circle that is subdivided into sectors. Each sector, it is bigger in proportion to the quantity it represents. So in this case, like for example, if we were told to present this information on a pie chart, if we use the totals, that is 2001, 2002, and 2003, we use these totals 440, 540, and 530 in preparing the pie chart. Then we need first of all to add all those totals, get the total. And then after getting the total, that is, was it what? These quantities were 440, you add them, you just add all of them. And then now, can somebody add all of them first of all, so that it can be easier for us? 440 plus 540 plus 530.
1010.
1010. So the total here, it is 1010. Now we have 2001. It is actually 440 over 1010, which is the total. Then you multiply by 360 degrees, because one complete circle gives us 360 degrees. You get that. You go to 2002, it was 540 over 1010 times 360 degrees. You compute that. And then you go to 2003, it was 530 over 1010 times 360 degrees. Then now, after doing those computation, you should come here. You should come here and have your pie chart. Have your circle, the center. This one is going to be smaller. This is how many degrees if you calculate? You start with the line, because that one will be smaller. It's going to have a smaller sector. And then we have the other one. The one that is going to have a bigger sector, that is simply a pie chart. It is a circle that's subdivided into sector. The bigger the sector, the bigger the quantity. Those are the ways that we can present the data. Those are data presentation methods. Anybody with a question?
Do we need to consider the decimal points, whether we're working with percentages or?
It is good, especially you can actually, if you do, even if it is one decimal place, even if it is one decimal place, so that when you add them, they give you 100. We minimize the error. One decimal place, it is actually possible for you to plot it on a graph. So one decimal is okay. Two decimal, I know it can be a problem. To plot maybe 44.25, it might be a problem, but maybe 44.4, you can be able to locate that point on a graph and mark it. One decimal place is okay. Any question? Anywhere you did not understand well and you need some more clarification? Well, that is actually the first bit. It is actually a topic on it, data collection and presentation. We have said data can be collected from two sources, the primary source or the secondary source. Primary source, it is where you are collecting it for the first time. And you can do that through observation, interviews, or through the use of questionnaires. That is the primary data collection methods: interviews, questionnaires, and observation. Then you can also obtain data through the secondary means. That is going to the books, the journals and all that, and get what other people corrected and documented, and you use that information in making the decision. Now, we have all the advantages of either of the two approaches, which is also good for you to understand. Then the data presentation, very important, from the histogram, the frequency polygon, the line graphs, the bar graphs, the pie chart. You also need to know how we prepare one, because possibly you can be asked a question from that particular area. Having said that, allow me to go to another area, which you still have the notes, which is the measures of central tendency. Measures of central tendency. They are also known as the averages. They are also known as the averages. So let me say this. Quite often, you have come across the terms like the mean, the median, the mode, from the time maybe you joined the primary up to the high school. Those, the mean, mode, and the median, they are our measures of central tendency. And what they mean is this. It is one individual value that is representing the entire group of data. So if, for example, 50 students sit for an exam, and then as a trainer or as a teacher, I go and mark your papers, and after marking, I want to know what was the mean score for that particular exam. So I simply add all your marks, and then I divide by the number of students, I will get my mean. And I will say, this is actually the performance for the entire class. So this case whereby we have got one value that is presenting the entire group is actually what we call measures of our central tendency. And those individual value, they can be in form of the mean, they can be in form of the median, or they can be in form of the mode. So the general performance of the class can be through calculation of the mean, which is also now the average, or it can be through determination of the median. The median is the mark that is going to be at the middle position. If I arrange from the smallest to the highest score, if I arrange from the smallest to the highest score, and I locate the mark that is going to be at the middle, then I can use that one to be the performance of the entire class. Alternatively, I can go to the mode, whereby I will choose the mark that was commonly repeated, that was highly repeated in that particular exam. And the one that was highly repeated can be used now to present the entire class as the general performance. So when we pick one individual mark or one individual value to represent all the others, those values are known as the central tendency values. Now, having said that, we need now to understand also this. When we talk about data, data is basically divided into either grouped or ungrouped. You can either have the grouped data or the ungrouped data. No, this is appearing, okay. For the ungrouped data, if I come and record your marks, I'm talking about the ungrouped here. If maybe you are 10 of you, I come and say your score is 45, 58, 61, 39, 80. This is how many? 1, 2, 3, 4, 5, and maybe 62, 39, and maybe 50, 56. Are they 10? 1, 2, 3, 4, 5, 6. We can have maybe 48. That is how you performed. When I list these figures down like this, I'm having what we call ungrouped data. When the information is just recorded in number form and separating each and every number with a comma, then we have the ungrouped data. For the grouped data, I can come here and say, maybe 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100. And say maybe from 0 to 20, I had 2 students. 20 to 40 marks, I had maybe 8 students. This one I had 5, this one I had 7, and this one I had only 1. When I have the information organized into classes from here up to here, that is called the grouped data. So data, whenever it is corrected, I can choose to have it as grouped, where I have the range from here to here, and then I put the number of items that fall in that particular class, or I can simply choose to write them down, all of them, and separating each by comma. When I have all of them written down, separated by comma, they are actually called the ungrouped data. But when I have it in this way, it is actually the grouped data. Now, as we shall be calculating the measures of central tendency, we shall come in here, calculating maybe the mean from the grouped data and the mean from the ungrouped data. How do I calculate the median from the ungrouped data from the grouped data? How do I calculate the mode from the grouped and from the ungrouped data? So you need to note this from the onset, that grouped data, it is data that is organized into classes where we have got the lower limit and the upper limit. And then we have got the number of items that fall in that class. Having said that, I want to go to another part of now calculating. I don't know why this, don't know how it came there, but we can do with it being there. So let us go to the mean as one of the measures of central tendency. How do we calculate the mean? Again, here we are going to have the mean from ungrouped and the mean from the grouped. In this case, we are referring to data from grouped data and from the ungrouped data. For the ungrouped, you can have maybe the height of students in a class. This is the height of students in a class. It is maybe in feet, maybe it is given as 5, 5.5, 6, 6.1, and maybe 6.4. This is the height of students. Now you are told, find the mean height. Find the mean height. Mean for this case, which is normally denoted by x bar, like that, it is given by the summation of x over n. The values that I have here are my x's. And then I divide by n, which is actually the number of observation. In this case, if I add all this, remember, anytime this sign is presented anywhere, this is the sum. The sign denotes the sum. So I'm going to come here and add. For me to have the sum of x's, I just add all my x's. So it's going to be 5 plus 5.5 plus 6 plus 6.1 plus 6.4. Then I divide by n. N is the number of observation where we have 1, 2, 3, 4, 5. We have got 5 students who are actually measured. So if you calculate this, it gives you the mean. It gives you the mean. What is the answer to be specific?
5.8.
5.8. So 5.8 becomes your mean. It is your x bar. 5.8 is your x bar. And you are done. There's no any complication in this. Just add all the items, then divide by the number. If they are 10 numbers, you divide by 10. If they are 6, you divide by 6. And that one gives you the mean. After obtaining the mean from the ungrouped data, remember this is ungrouped data, we can go to the mean from grouped data. For grouped data, the mean is normally obtained by the formula, the summation of fx over the summation of f, where x represents the midpoint of classes, and f, it is the frequency. F is the frequency. So let us have an example. You can be told the performance of students in a class was recorded as follows. So we have got the marks here, and we have got the number of students. So you are given this. The marks, it is, let us start from 10 to 20, 20 to 30, 30 to 40, 40 to 50. Maybe the exam was out of 50. So those who scored between 10 and 20, they were 5 students. Those who scored between 20 and 30, they were 11 students. Between 30 marks and 40 marks, they were 8 students. 40 and 50, maybe they were 3 students, like that. So the number of students here is going to be our F. This is the number of times each particular class is having, or the number of objects that are going to be in that particular class. So what you need to do, you need to determine your X, which we have said the X is the midpoints of the classes. These are the classes from here to here. This is the class of 10 to 20, the class of 20 to 30, 30 to 40, like that. So the classes are here. So you need to determine the midpoints. So these are actually the midpoints. How do you get the midpoints? You add the lower limit plus the upper limit, then you divide by 2. In this case, if you add the 2 and divide by 2, this is 30 divided by 2, you find it is 15. This is 20 plus 30, 50 divided by 2, it is 25. This is 30 plus 40, 70 divided by 2, it is 35. That 40 plus 50, 90 divided by 2, it is going to give you 45. So those are your x's. The x is the midpoint of the classes. After having your x's now, you can get your fx. The fx. Fx simply means you multiply the frequency times the x, the midpoint. Frequency times x, frequency times x, frequency times x, so that you can get the fx. So we start 5 times 15.
75.
75. 11 times 25.
275.
8 times that 5.
280.
280. 3 times 45.
135.
135. So you add, because the formula says the mean, which is x bar, is given by the sum of fx over the sum of f. So we can sum all our fx's so that we can get the sum here, and we also sum our f's so that we can get the sum of f here. So can you add all the fx's and all the f's so that we can get those totals?
The F is 27.
This is 27. What about the f-axis?
765.
Come again?
765.
765. Therefore, our mean, or x bar, is going to be 765 divided by 27. That is going to be our mean.
28.33.
That is going to be the mean. 28.23. Okay.
33.
33, sorry. So I changed this one to be 33, like that. That is basically how we do it, but we can have another example because mean is also very important part that you need to understand. You can be given, maybe you are given the profits of farms. You are given the profits of farms, and here you have the number of farms, which is actually our F. Now you are asked determine the mean profit. Let's say this profit is in thousands. The figures we have here, it is in thousands. So we have maybe 50 to 100, 100 to 150, 150 to 200, 200 to 250. Now, so the number of profits that are, the number of farms that registered a profit of 50 to 100,000, maybe they were 7. 100 to 150,000 profit, maybe we had 13 farms. These were 8, and maybe this one, they were 6. Those are our Fs. For us to be able to calculate the mean, what we need, it is a column for X, which you will always, this one you will not be given. You must prepare it yourself, and the column for Fx. These are the two columns that we need. These are the two columns that we need. We need a column for X and a column for Fx. These ones you must create yourself. X, we said it is the midpoint. You just add the lower limit plus the upper limit divided by 2. So this is 150 divided by 2. It is actually 75. This is 250. 100 plus 150 is 250 divided by 2, which is 125.
125.
The other one is going to be 175. You just add the 2 and then you divide by 2. Confirm whether whatever I've written is correct. This is 250 divided by 2. 175. This is 450 divided by 2, which I think is okay. Now, after getting the X, now you multiply the value for F times the X so that you can fill this column down. 7 times 75, 13 times 125, 8 times this, as we fill here, so that we can get the sum here and the sum here. We need the sum for F and the sum for Fx, and we are good to calculate the mean.
$525.
525. Next one.
1625.
Next one.
1400.
Next one.
1350.
So can you get now the total?
$4,900.
What about the total for Fs? 20.
34.
34. So we can create,
34.
okay, yes. We can calculate our X bar, or the mean, which will be equal to the sum of Fx, which is 4,900, over the sum of F, which is 34. You get that mean.
144.12.
And note, what you need to note.
144.
144, okay.
Yeah.
Okay, thank you. Now what you need to note is these profits, they were in thousands. So once you get your mean, you should remember to multiply 144.12 times 1,000, so that now you can have it in thousands. 144, 120, you multiply by 1,000 because these profits, they were actually in thousands here, so that now your actual answer should be correct. That is actually on the mean. The mean, you don't need to do anything. If it is for ungrouped, add and then divide by the total number of the total number that you added. For this one, you just need the column for x and fx. Add the fx, add the f's, divide the fx by f. You have the mean. Let us go to the next measure of central tendency, and which is actually the median. Allow me to unshare this just a minute. So we are on the other measure, which is the median. The median. The median is actually the value that occupies the mid-row position. The value that occupies the mid-row position is what we call the median. So again here, we shall talk about the median, first of all, from ungrouped data. Median from ungrouped data. Don't forget the ungrouped data, it is the data that is behaving like this. That is actually the ungrouped data. For us to be able to calculate the median from the ungrouped data, there's a formula that says the median position. The median position, for you to locate the median position is normally given by n plus 1 over 2. You get the position. So it is going to be somewhere. It is a position. It is not the median. It is the position of the median. But first, arrange the data in ascending or descending. You cannot get the median by the data the way it is. You need first of all to arrange so that we can get the position of the median. So by arranging here, it simply means either we start with the highest to the smallest or the smallest to the highest. But we normally like using the smallest to the highest. Like in this case, the smallest is what it is 2, and the 2 it is appearing twice. So we have 2, 2, so we repeat it. Then we go to 3. After 3, the next one is 8. The 8 we go, we have 10, 10, and then 12. And then the highest is 15. Let me add the other one. Maybe we had 17 here. I want to start with the median when we have got odd numbers. So in this case, we had 1, 2, 3, 4, 5, 6, 7, 8, 9. We had 9 observations. So if we want to locate the median, we can apply this formula. Remember, n, it is the number of observations. How many values do we have? We have got 1, 2, 3, 4, 5, 6, 7, 8, 9. So our n in this case, it is 9. So the median position, the position here, it is going to be n plus 1, which is 9 plus 1. Then we divide by 2, which is going to be 10 divided by 2, which is simply means the fifth number or the fifth observation. It is actually our median. So we say this is the first, second, third, fourth, fifth. So the fifth one is this 10. So our median is 10. So this formula, it does not give you the median. It gives you the position of the median after arranging those observations from ascending, from the smallest to the highest. That is ascending or descending. It does not give you the median. So don't come here and say 5, and then you say the median is 5. No, 5, it is the position of the median when those observations are arranged from the smallest to the highest or the highest to the smallest. But you can also You can also choose to do what we used to do in high school or primary. You just count 1, 2, 3, 4. This side 1, 2, 3, 4. You find that this is the number that is enclosed. This is the number that is enclosed. So for the odd, it is going to be so direct. For the odd number is going to be so direct. You are going to have only one number that is occupying that position. What about if we have the even number of observation? If, for example, now you are given maybe the profits of farms in 1,000, it is maybe 120, 130, 90, 160, 85, 65, and maybe again 120. These are how many? 1, 2, 3, 4, 5, 6, 7. Let me add maybe 111. These are the profits of 8 farms in terms of thousands. Now you are told, calculate the median profit. Calculate the median profit. So first of all, arrange them. Arrange them from the smallest to the highest. So the smallest is what? Okay, this is, can you give me the smallest to the highest? Yes.
65.
65, then followed by
85. 90. 111. 120. 120. 130. Then 160.
That is it. Then you can come here and you say the position of the median. The position of the median is n plus 1 over 2. In this case, our n is going to be what? The number 1, 2, 3, 4, 5, 6, 7, 8. Our n is 8. So it is an even number. So we are going to have the position is going to be 8 plus 1 over 2, which is 9 over 2, which is the same as 4.5. The 4.5. So what you need to do is to come here. 4.5 will be where? 1, 2, 3, 4. 4 is here. 4.5, it is actually in the middle here. Because up to here we have the 4 numbers, then 4.5 is going to be the middle. So anytime we have got the even number of observation, we are going to have the median as the average of the two numbers between which that median lies. Because it lies in between 111 and 120, the median would be equal to the average of those two numbers. The average of those two numbers, which is 111 plus 120, then we divide by 2. You get the average of those two numbers between which the median lies. If you get the average,
15.5.
that is going to be the median. That is the median from ungrouped data. Let us do the last one now, which is the median of the grouped data, and we stop there. When we meet on Saturday, we start from the mod. For grouped data, median is calculated using this formula. It is given by L plus N over 2 minus C over F. And then we multiply by I here. This is the formula that we normally use to calculate the median for the grouped data. L, it is referred as the lower class limit of the median class. N is the total frequency. N is the total frequency. C is the cumulative frequency, CF, cumulative frequency above median class. Cumulative frequency above median class. F, it is the frequency of median class. And then I, it is the class, it is the class interval. It is the class interval. So anytime we have the grouped data, we need to have these values down. We need to have these values down, but let me demonstrate it using this example that I'm going to give. If you are given this table or a table like this, maybe you are given the sales that are made by organizations in a particular week. So we have maybe 0 to 5, 5 to 10, 10 to 15, 15 to 20, maybe 20 to 25. These are sales, and let us say they are in 1,000 shillings. And number of organizations that are making those sales, number of organizations, which is actually going to be our F. The organizations that are making the sales of 0 to 5,000, let me draw this. Maybe there are 3 organizations. They are 8, they are 9, maybe these are 6, and maybe there are 5 organizations. 0 to 5,000 and all that. When you are locating or calculating the median, when you are calculating the median, you must have the column for cumulative frequency. You must add the column for cumulative frequency, which is denoted by CF. And how do we have the cumulative frequency column? You start with the first frequency, which is 3. Then you go adding 3 plus 8 is 11. 11 plus 9, it is 20. 20 plus 6, it is 26. 26 plus 5, it is 31. So our N, from our formula, we said the median is given by L plus N over 2 minus C over F times I. So we can start by getting them now. Our N, it is the total frequency, which is the same as that one. If you add this, the summation of F is going also to give you that one. So our N is that one. So we have that value, it is sorted. Then we do N over 2 to locate the median class. Or I can interpret this one for you before we go far. With the cumulative frequency, it simply means that if we organize these farms from the farm that is making the lowest sales to the farm that is making the highest sale. Remember, the lowest sale it is 0, the highest sale is 25,000. So if we organize them, we arrange them from the smallest to the highest in terms of sales. The first three farms, the first 3 from the bottom, they are making the sales of 0 to 5. Then this 11 simply means the first 11 are making a sales of 0 up to 10. You expand the gap. It was 0 to 5, now it is 0 to 10. So 0 to 10, there are 11 farms. That is the 3 for 0 to 5 plus the 5 to 10, which they were 8. So from 0 sales to 10,000 sales, we have 11 farms. From 0 to 15,000 sales, we have got 20 farms. That is 3 for the first class, plus this, they give us 20. From 0 to 20,000 sales, there are 26. And from 0 to 25, it is now all of them, which is that one. So for us to be able to locate the class where our median will fall, we normally divide the total frequency divided by 2, so that now we can be able to know in which class among these is our median going to fall. So if you do this, our N, we have said it is that one. So it's going to be that 1 over 2. You will find that is going to be 15.5. Now, where will 15.5 fall in the cumulative frequency? That is what we need to ask ourselves. Let me assist you in interpreting that. The first 3 are here, the first 11. So the 15.5 farm is going to be here. We cannot say it is here because already hatujafikia ya 15. We cannot say it is here because we have passed. So the 15.5 farm, it is going to be in these 20 farms that we have here. So because our median is going to be here, the number 15.5, position 15.5 is going to be here, we now consider this one as our median class. This is actually our median class. So we can come here and we say median class is the class of 10 to 15. I don't know whether that is clear, because first of all, we need to locate the median class for us to be able to get these other values. The L, the C, and the F, they can only be obtained after you have located the median class. And how do you get the median class? Get the total frequency, divide by 2, and then now you can be able to locate where is that value going to fall in the cumulative frequency. We cannot say it is here because we are looking for the farm number 15.5. This is only 3, this is 11. We are not yet to position 15.5. So position 15.5, it must be among these 9 that we added so that we get 20. So that is why we are saying this is going to be our median class. If we have located the median class, then we are sorted. Then we come here. R, we said it is the lower limit of the median class. If the class is 10 to 15, this is going to be the lower limit of the median class. So our R is 10. Then our N we have. C, we said it is the cumulative frequency above the median class. If this, remember 20, it is the cumulative frequency of the median class. The one that is above, the cumulative frequency above, it is 11. So our C is 11. And then our F, it is the frequency of that class, which is 9. Frequency of this class, which is 9. And then our I, it is the class interval. You just subtract the higher limit minus the lower limit, which is actually 5. And you have all the values that you need. After having noted that, now we can be able to calculate that median. Let me lab this part. So our median for that case now is good. It's just a matter of substituting these values. Our R here, it is 10 plus into bracket n over 2. N is 31 over 2, which actually we calculated here to be 15.5, minus C, which is 11, over F, which is 9. Then we multiply by 5, which is our I. So you will find that this is going to be 10 plus 15.5 minus 11 is going to be 14.5 over 9. Then here we need to multiply this part by 5. Can somebody work for me that? 15.5 divided by 9 and then you multiply by 5. (14.5) divided by 9 times 5.
I think it should be 4.5 over 9.
Oh, sorry. You are okay. You are okay. You are very okay. Sorry? 4.5 over 9 times 5. You get it, Izo?
2.5.
2.5.
2.5. So if you add it to 10, it's going to be 12.5. And now, as you get the answer, you always look at the values that you are given on the classes. If they were in thousands, then you have to multiply 2.5 times 1,000. so that you can get 12,500. That is actually the median sales for that particular case. I want to do another one for the sake of clarification. For the sake of clarification, if we were given the marks, maybe the students scored 0 to 5, it was a cut, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to that. It was just a cut out of that. And you are told you calculate the median given the frequencies, they were as follows. You are given the frequency. Those who scored between 0 to 5, they were maybe 2 students. 5 to 10, they were 8. 10 to 15, they were 14. 15 to 20, they were maybe 19. This one, they were 9. And maybe this one, they were 5. You are told now, calculate the median marks. What you need to do, come here and construct your cumulative frequency column. Your cumulative frequency column, start with the first frequency, which is 2. You go adding 2 plus 8 is 10. 10 plus 14 is 24. Plus 19, that is the 23, 33.
43.
43, yeah. And then this one is going to be 52. And this one is going to be 57. So the figure that appears last here is your n. So if you also add this one, it's going to give you 57. So our n is 57. So locate the median class by doing n over 2, which is the same as 57 over 2, which is actually 20.
28.5.
Now come to the cumulative frequency. To locate the median class, after doing the n over 2, come to the cumulative frequency. Where will it be our 28.5?
In class 15 to 20.
15 to 20 is going to be actually in this 43. Yeah? You cannot take the lesser number. Eh? You cannot take the lesser number. You take the number that is bigger. You take that particular. You cannot take, because hapa in 24 hatujafikia 28, so it must be here. Eh? So 15 to 20 is our median. Median class is going to be 15 to 20, the class of 15 to 20. Having noted that, L, it is the lower limit of that class, which is 15. And then C, it is the cumulative frequency that is above. This is the cumulative frequency of the median class. The one that is above, it is 24. Then F, it is the individual frequency of that class, which is 19. Then our I, it is the class interval. You get the difference between these limits, which is 5. Now you can be able to calculate the median as given by L, which is 15, plus n over 2, it was 28.5, minus C, which is 24, over F, which is 19. Then the whole of this part, it is multiplied by 5. You work out that, then you are done. That is how we calculate the median from the grouped data. Median from the grouped data. The key thing is for you to locate, to know, the moment you have known how to locate the median class, then your problems are sorted. It is just a matter of having the cumulative frequency. The last value here, it is your n. Divide by 2, so that you can know where the median will lie. And actually, if we calculate this median, you are going to find it is going to be a value that is going to be between these two. It is going to be a value or an answer that is between 15 and 20. it cannot be actually outside that because it is our median class. So the median will be in between 15 and 20. But we can finish actually. So this one is going to be 15 plus, this is 28.5 minus 24. I think it is 4.5 over 19. Then you multiply by 5. Can you do the whole computation? 4.5 divided by 19, and then you multiply by 5. The answer you get
1.18.
plus 15, 16.18.
8.
That is done. Actually, that is how you calculate the median. That is how you get the median. Any question as far as the discussion for today is concerned? Any question? Okay, you all seem to be comfortable. Can I end the class at that point?
Yes.
Okay, if the answer is yes, then I say we end the class at that point. Thank you for coming on board, and may you have a blessed week
You too.
and also
You
have
too,
a
thank
good
you.
night.
You too.
Thank you.
Okay.